So continuing with our paper 2 content, today I'm going to be covering the topic on hypotheses. And this is something which will only come in paper 2. However, it does not have to come. If you look at past papers, there are a few years where they have given a question on hypothesis and a few years where they haven't. So, and even if the question does come on hypothesis, it's at most a 2, 3, maybe even a 4 mark question, like 2 parts, 3 parts to it. So not a lot of marks in the hypothesis question, but there are different types of hypothesis questions that could come, and I will discuss each one of those with you. So students at times they decide to leave this out because they're like, if it's only for 2 or 3 marks, might as well leave it. But I would urge you guys to go over this. It's pretty easy. It's fun to solve as well. And if it does come, it's an easy 3 to 4 marks. So why let those marks go? Because, it could be the difference between you getting an A or a B. So let's discuss what an aim and a hypothesis is. A hypothesis is a prediction about the results of a study, whereas an aim is what the purpose is of the study. What is it that you're trying to investigate? And you should know these definitions because, again, in past papers, they have asked questions such as what is the definition of an aim or what is meant by an aim, using any example as a study, any example of any study. So that could be like a 2 marker. So you should definitely know the definitions of each. An example of an aim is like the Milgram study. We want to test if people will be obedient to an authority figure. Whereas the prediction would be, we're predicting that people will show obedience to an authority figure. So the difference is essentially the phrasing. In the aim, you're stating what you are planning on doing. Whereas in a hypothesis, you shouldn't use the term is. Instead, you should use the term will, because you're making a prediction about what you think will happen. So a prediction could be, let's say, if you look at my research method presentation, I give an example of a study where I want to test the impact of the AC on your performance in a test or concentration during a test. So my aim is to see if AC or air conditioning has an impact on concentration and performance. Okay, that's my aim. My prediction would be that a lower temperature or a higher temperature will have a greater impact on students' performance, or air conditioning will improve students' performance in a test. So that is a prediction. It's not something that has happened, because then that would be a result. Instead, it's what I'm predicting my results will be. And there are 3 types of hypotheses which we are tested on in the syllabus, which we refer to as a one-tailed, a two-tailed, and a null hypothesis. Another term for a one-tailed hypothesis is a directional hypothesis. We should know both of these terms. And another term for a two-tailed hypothesis is a non-directional hypothesis. Okay, I've given the definitions of each over here. A one-tailed or a directional hypothesis is basically a prediction where you are specifying the result. So there isn't any ambiguity in the result in a one-tailed hypothesis. So for example, if I'm comparing performance of students in an AC on room and an AC off room, I'm looking at 2 different conditions, an AC on condition and an AC off condition. And I want to see the results. So if I'm making a prediction that students will perform better in the AC on room as opposed to the AC off room, this would be an example of a directional hypothesis. It's a prediction because I'm saying that this is what I think will happen, but I'm giving it a very specific direction. I'm giving the result a direction. I'm pointing it towards one of the 2 conditions that I'm testing. So I'm saying the results will be better in the AC on as opposed to AC off. So my results are being directed towards the AC on group. I'm saying they will perform better. That is an example of a one-tailed or a directional hypothesis, where you're very clearly stating which of the 2 conditions will have a greater impact. A non-directional hypothesis or a two-tailed hypothesis is one where you are predicting that there will be a difference between the 2 conditions, but you're not stating which one will have a greater impact. So a two-tailed hypothesis would simply be an example, taking the same example, that there will be a difference in the performance of students depending on whether they're in an AC on room or an AC off room. So focus on the two examples of the one-tailed, two-tailed. In the one-tailed hypothesis example, I'm very clearly stating that students will perform better in the AC on condition, not in the AC off. So I'm giving the result a direction. In the second non-directional hypothesis example, I'm stating that there will be a difference. Students may perform better in the AC on, or students may perform better in the AC off. So I am saying that one condition will produce better results than the other, but I'm not specifying which condition is going to do that. So I'm not specifying a direction. So there is more room for well, it's more ambiguous, you can say, because you're not specifying any particular condition. You're not saying that this condition will have a greater impact. So you can leave it open to interpretation, and you can still kind of assume, okay, maybe students may perform better in AC off, or they may perform better in AC on. That's not being decided. But what we are saying for sure is that there will be a difference. One group will definitely perform better than the other. The only difference is that in a one directional, I'm specifying which group will perform better. But in a non-directional, I'm not specifying which group will be performing better. Okay. A null hypothesis, however, is when you're rejecting it altogether. You're rejecting the aim altogether. So a null hypothesis would simply be that there will be no difference in the two groups. So whether you take a test in the AC on group or whether you take a test in the AC off group, it doesn't matter. The performance will be the same in both. So essentially you're rejecting the aim, because by predicting this as a result, by having this null hypothesis as a result, you're simply saying that AC will not have any impact on performance, which is your aim, right? You want to see if AC will have an impact on performance. When you're predicting that this will not be the case, you're rejecting the aim, and that essentially is going to be a null hypothesis. So I just gave a brief overview. I'm going to obviously get into examples to help you understand better. I've given a little study hack over here. This is a statement that you can kind of use. If you can kind of memorize this statement and just apply it in your examples or in your answers, you will get full marks, because students have different ways of phrasing their answers for one-tail, two-tail hypothesis, and at times they struggle when it comes to using terms or correct words, and they end up writing like a 5-line answer just to describe their hypothesis when you can simply do it in 2 lines. So for those of you who are struggling to come up with the correct words, struggling to phrase your sentence correctly, you can just maybe remember this little hack that I've given you, this statement. So it says over here that the best way to write a one-tailed hypothesis is to pick one variable over the other and simply state that this has a greater effect on the behavior rather than the other. So for example, you want to see if XYZ behavior, which is the DV, is affected by variable A more or variable B more. So let's take again the example. Let's say variable A is AC on, variable B is AC off, and the behavior or the DV is your performance. So in a one-tailed hypothesis, just pick one variable over the other and say that this will have a greater effect. Say AC on will have a greater impact on performance in a test rather than AC off, right? So you can simply just write your one-tailed hypothesis by this one line, this one phrase, this one sentence. If you want, you can even say AC off will have a greater impact on performance than AC on. Now, obviously, we believe that AC on will have a greater impact than AC off, but remember, it's a prediction. So even if you predict that the AC off condition will have a greater impact, logically it may not make sense, but you cannot be marked incorrect on it because it's a prediction. As long as you're saying either of the two conditions is having an impact, it's correct for a one-tailed hypothesis. I'll give you another example. We'll be looking at a few, but let's say I want to test if students will study better. I'm not sure if this is already an example in the notes, but I'll still use it. Let's say students want to, let's say a researcher wants to test if students will perform better in their exams if they study through YouTube videos or if they study through the textbook. Okay, so you should be able to identify over here that the IV would be the YouTube video condition or the textbook condition, and the DV would be the performance of the students in the exam, the results that they get, right? So we've got the two conditions of the IV, studying from textbooks or studying from YouTube. And the DV we have the results. Now, using this statement, variable A will have a greater impact on XYZ than variable B. Let's apply this statement for this example. Okay, so remember, this is a one-tailed hypothesis. So I have to give my behavior of the results of the students a particular direction. I can simply say, studying from YouTube will allow students to get a greater or a better result compared to studying from the textbook. That's it. That's a one-tailed hypothesis. I can even say students who study from a textbook will get a better result than students who study from YouTube, right? So you can pick either one, it doesn't matter, as long as you are favoring one over the other, okay? Now, some mistakes students tend to make is they may say studying from a textbook, students will get better grades if they study from a textbook. Now, the problem with that is you're not making a comparison. If you're saying students will get a better result studying from a textbook as opposed to what? So make sure you write the whole thing. Don't write half an answer. And I've seen a lot of students make this mistake. So instead of saying that students will get a better result if they study from the textbook, say students who study from a textbook will get a better result as opposed to studying from YouTube. Or students studying from YouTube will get a better result as opposed to students who study from the textbook. Okay, so make that comparison. Pick one over the other and mention the other as well. And mention what behavior is being affected. Mention that the results will be better or worse or whatever. Okay, so this is an example of how you can write a one-tailed or directional hypothesis. Now, another way, or not another way, a hack or a statement that you can use similar for the one-tailed hypothesis, for two-tailed hypothesis is this statement. There will be, and if you notice, I've written will in bold because I told you guys that a hypothesis is always a prediction. Okay, it hasn't happened as yet. You're predicting, you're forecasting that this is something that could happen, which is why your statement, because a lot of students I've seen, they write, this is, or this has happened, or this should happen. Well, should is also technically okay, but the best phrasing would be to say that this will be the case, because you're saying that this hasn't happened, but it could happen. So you should say there will be a difference in XYZ behavior depending on either of the two conditions of the IV. So this is just a little one-line phrase that you can kind of memorize and apply for a two-tailed hypothesis. So start your two-tailed hypothesis by saying that there will be a difference in the behavior. What is the behavior? The results of the students. So there will be a difference in results of students depending on whether they study from textbooks or from YouTube. So I'm saying that one will be beneficial compared to the other, but I'm not specifying which one. So this would be an example of a two-tailed hypothesis. This would be the phrasing you can use for a two-tailed hypothesis. Okay. Let's see. Yeah. So let's look at a few questions now. I've also given a phrasing for a null hypothesis if you want to know. For a null hypothesis, okay, let's discuss this. So there are two ways in which we can phrase a null hypothesis. The very simple, easy way is by saying any difference is due to chance. So this is one way of writing a null hypothesis. Any difference in the results of students in a test, depending on whether they study from YouTube videos or the textbook, is due to chance. So you're not saying that it's because of this condition or that. You're saying it's only because of chance. It's due to luck that they perform better in one as opposed to the other. So that's a null hypothesis. The other way of writing a null hypothesis is by saying there will be no difference in the results of students in a test depending on whether they study from a textbook or YouTube videos. So if you're confused and you're thinking, isn't this the same as a two-tailed hypothesis? No, it's not, because in a two-tailed hypothesis, we said there will be a difference. In a null hypothesis, we're saying there will be no difference. Okay, the rest of the phrasing will be the same. So a non-directional two-tail will be there will be a difference in the results depending on whether you study from a textbook or from YouTube videos. Whereas a null hypothesis is there will be no difference in the results depending on whether you study from textbooks or YouTube videos. Or if you don't want to write that, you can just simply say any difference in results of students, depending on whether they study from YouTube videos or textbooks, is due to chance. Okay. Make sure, again, you make the comparison. Make sure you mention both the variables that are being compared. So hopefully you have, and I'll share these notes with you guys as well. So for those of you who are on my WhatsApp group, I will share this entire presentation with you there. Let's look at a few examples now. So let's start off with an easy one. So the question is, a researcher wants to investigate, or a researcher wants to test if lighting will have an impact on productivity of workers at a factory. Okay, write a directional hypothesis or a one-tailed hypothesis. Okay, so both mean the same thing. First, let's identify the IVDV. So we want to test if lighting will have an effect on productivity of workers at a factory. Now, lighting is obviously going to be the IV, and it's having an effect on productivity. So the variable that is being affected is the DV, which is productivity. And what is it affected by? It is affected by the lighting. So lighting will be the IV. So we've identified the IV and the DV, right? But what are the two conditions of the IV? That is something that is not mentioned in the question. Now, this is a good place where I can, or a good point where I can raise the issue of operationalization. Okay, so this is an example where I will explain to you what operationalization is. Now, operationalization of the independent variable is simply describing or defining the IV conditions. So over here, the IV is lighting. And we know that we have to have at least two conditions, right, to compare. So if they haven't given you the two conditions, you can choose yourself as to how you want to operationalize it. So you can set your experimental and control condition yourself. So if the question had said that we want to test if students or if workers will have high productivity in brighter lighting or dim lighting, then it would be already operationalized for you. But they haven't operationalized it. They've just said that the IV is lighting. So now you can choose to operationalize it yourself. One student may operationalize it by having one condition as bright lighting and the other condition as dim lighting. Another student could operationalize it by having two different colors of lighting. So another student could say that one condition could be yellow lighting and the other could be white lighting or blue lighting, whatever. It's completely up to you how you want to operationalize it. Okay. So let's go with an easy one, brighter versus dim lighting. So a directional hypothesis, workers will have greater productivity in brighter lighting than in dim lighting. Okay. If you want to say workers will have greater productivity in dim lighting compared to bright lighting, that is also correct, because remember, it's a prediction. Workers will have greater productivity in yellow lighting as opposed to white lighting. That is also correct. Okay, so they haven't given you the condition, so you can decide, you can operationalize it yourself. So that's how we operationalize an IV. We choose the two conditions, we define the two conditions. So if I say that the race of the victim in Pilyavan is the IV, how is it operationalized? By a black victim, by a white victim. Okay, that was already done by Pilyavan. Pilyavan already operationalized it. Another example, one of the other IVs was the condition of the victim. How was that operationalized? By having a drunk victim who smelled of alcohol and was holding a brown paper bag with an alcohol bottle, or a cane victim condition, where the victim was pretending to be ill and holding a black color cane. Okay. A few other examples, the Andrade study. So we have the doodling. We want to see if doodling affects concentration. So doodling is the IV, and how is it operationalized? By the doodling condition and the control condition. Okay, And it's good to at times elaborate on the two conditions. So the more you elaborate, the more you're operationalizing it. So you can say the doodling group was operationalized by giving sheets of paper with alternating rows of 10 squares and 10 circles for the participants to shade into, for them to doodle into. And the control group was operationalized by the participants being given an A4 size sheet of lined paper without any shapes for them to doodle into. Okay, so you just kind of in detail elaborating on the IV conditions or just describing them. So that's how you operationalize the IV. Let's take another example. Um, what other examples can I give you from studies that have an IV-DV? Perry? What was the IV in Perry? The IV in Perry, one of the IVs in Perry was empathy, right? And how was empathy operationalized? High empathy or low empathy? And if you want to go into even more detail, which we should, we can say the IV of empathy was operationalized by the participants having either high empathy, which was a score of 40 and above in the IRI questionnaire, or having low empathy, which was operationalized by participants having a score of 33 or below in the IRI questionnaire. Okay. Um, Oxytocin administration, that was operationalized by participants being given either a dosage of oxytocin or a dosage of a placebo, which was basically a saline solution. So you're just describing the two conditions of the IV. That's how you operationalize the IV. And in the studies in our syllabus, the IV will be operationalized by the researcher. But in paper 2, when in my next video, hopefully when I post it soon, and we come across a few questions, you will see that there will be some hypothetical scenarios in section B in paper 2, where they'll give you the IV and you may be required to operationalize it yourself. So you have to use your own common sense, your own knowledge of well, not even knowledge of research methods. It's mostly common sense. You just have to use your intelligence a little bit. You just have to use your common sense, and you have to come up with what you believe is a good way to operationalize the variables. So we'll come across a few questions like that in this presentation as well. So for now, let's get back to this example. Workers will have greater productivity in brighter lighting than in dim lighting. Okay, that's a directional hypothesis. Let's look at an example of a non-directional hypothesis. Okay, and remember this could be for like 1 mark or 2 marks. Okay, so not very high scoring, and not very in terms of marks. It's not a lot of marks, so it's an easy 1 or 2 marks that you can get. In the non-directional hypothesis, I am simply saying that there is a difference, but I'm not specifying which condition is going to have a greater impact. There will be a difference in productivity depending on whether the lights are bright or dim. Simple. So maybe light, so I'm saying one will have a greater impact on the other, but I'm not specifying which one. The moment I specify, it's a one-tailed, it's a directional hypothesis. But when I'm saying that there is a difference but not specifying, it's a two-tailed. So what should the null hypothesis be? Let's look at these statements. So you can say any difference in productivity of workers depending on whether the lighting is dim or bright is due to chance, or there will be no difference in productivity of workers depending on whether the lighting is dim or bright. Now, in a null hypothesis, if they ask you to write a null hypothesis, you don't have to give both. That's why I'm saying or. You can either write this statement or you can write both. If you want to write both, you can, but there's no need. Just write either one, whichever one you're more comfortable with. I prefer that you write the second one because I don't know. I just feel like it's a little more detailed. So it's you're specifically stating that there is no difference. So I think if you're rejecting the aim, then by saying that it's due to chance, I don't know. I mean, it's considered correct, but for me, I'm more convinced about the second one than the first one, obviously. But you can go with whichever one you favor, whichever one you remember at the time, whichever one you find easier. Either one will be marked correct. And I've given the example right here. There will be no difference in productivity depending on whether the lights are bright or dim. Any difference in productivity of workers depending on whether the lights are bright or dim is due to chance. Okay, let's look at another example now. A researcher wants to test if cats will be more playful or dogs. So playfulness, remember the behavior is always the DV. And what is it affected by? The animal, whether the animal is a dog or a cat. So animal is IV, playfulness is DV. Animal has already been operationalized by cats and dogs. and playfulness is the behavior that we're looking at. Write a one-tailed or directional hypothesis. Dogs will be more playful than cats. You can write cats will be more playful than dogs. What you cannot write is monkeys will be more playful than dogs, because over here they've already told you the two animals. The previous example, they hadn't told you the two conditions of lighting, so you could come up with your own. Over here they have operationalized it. So you have to stick to cats and dogs. A non-directional two-tailed hypothesis, there will be a difference in playfulness between dogs and cats. And a null hypothesis, there will be no difference in playfulness depending on whether the animal is a dog or a cat, or any difference in playfulness depending on whether the animal is a dog or a cat is due to chance. Okay. Now, question number 3 is slightly different. Okay, so this is another type of hypothesis question that you could experience. A researcher wants to investigate if people will remember scenes from, I don't know what's going on over here with the phrasing, but a researcher wants to investigate if people will remember scenes from a romantic movie more or a horror movie. Okay, so the genre of the movie is the IV, romantic and horror, so already operationalized, and the DV is their memory. If you want to further operationalize this, you can. So you can actually come up with examples of romantic and horror movies. So an example of a horror movie, you could say maybe, what was that horror movie? The one with the scary nun, Insidious? I think that was the name. And romantic movie, you can come up with Notting Hill, if any of you guys have seen that. If you haven't, you should. It's a great movie. Although I'm not a big fan of romantic movies, but it's the one that I really do like. Horror movies I completely avoid. I cannot watch horror movies. I get really scared. Anyways, so if you want to further operationalize it, you can give examples of either of the two. But they're not asking you to operationalize it any further, so there's no need. There will be questions where you will be required to operationalize it. So when we come across those examples, we can look at them. But for now, let's stick to just the terms romantic and horror. But let's see what the question is. Why is it different? Because it's saying write a one-tailed or directional hypothesis with a clearly defined IV and DV. So here is something new. Clearly defined IV and DV. If they give you this, don't get scared. Don't be like, what the heck is this? What are we supposed to write here? It's pretty simple. Go on with your business as usual. Just write your regular one-tailed hypothesis, give a full stop, and just give an additional statement in which you're clearly saying that, okay, this is the IV of the study, this is the DV of the study. That's it. So let's see my answer. I start off by writing the one-tailed hypothesis. People will remember scenes from a horror film more than from a romantic film, full stop. The IV is the movie and the DV is memory. If I want the IV, I can write the IV is the movie, in brackets you can write horror or romantic films, and in the DV is the memory. So this would be an example of a question where you're supposed to write a clearly defined IV and DV. Now, a two-tailed hypothesis with a clearly defined IV and DV. There will be a difference in memory of scenes depending on whether the movie is a horror movie or a romantic movie. The IV is the movie and the DV is memory. Null hypothesis, there will be no difference in memory of scenes depending on whether the movie is romantic or horror, or any difference in memory of scenes depending on whether the movie is horror or romantic is due to chance. So by now, hopefully you guys have gotten the hang of it, and you probably by now are familiar with these phrasings. So every time you come across a question on hypothesis, just remember to use these terms. Okay, there will be a difference, or this group will perform better or have a greater impact than the other. And in case of a null hypothesis, no difference or any is due to chance. Okay, now let's get to a slightly tougher one. For a correlational aim, you will state the type of correlation. So far we've been looking at an IV and DV. Go over my research method notes and go to the slides on correlations, and you will see that a correlation study is one where there isn't an IV and DV. So when we don't have an IV and DV, we cannot use the sentence that we've been using so far, that one will have a greater impact than the other. Because when we're saying that there is an impact, we're saying that there's an IV and a DV. So cause and effect or impact is not being looked at in a correlation. Relationship is being looked at in a correlation. So how do we write a correlational hypothesis? It's actually really easy. We know that there are two types of correlations, right? There's a positive correlation or a negative or slash inverse correlation. So for a directional hypothesis, for a correlational aim, you are simply just stating what you think the correlation will be. You're saying the two variables will be positively correlated, or the two variables will be inversely correlated, negatively correlated. So that's a directional hypothesis because you're still giving a direction. You're saying that the two variables will be either positively correlated or negatively. So you're giving a definitive answer. Whereas in a non-directional hypothesis for correlation, you're saying that there will be a relationship between the two variables, but you're not specifying. So you're leaving it to, again, up to the student to up to whoever is doing the study, that it could be either a positive or a negative correlation. We're not specifying which one. We are saying that there will be a relationship, but again, there's that ambiguity factor again in a two-tailed hypothesis where we're not specifying exactly what the result is going to be. We're just saying that there is a difference, but we're not being very specific about it. And in a null hypothesis, we'll be rejecting it altogether. We'll say that there is no relationship. There is no correlation between the two variables. So this is actually really easy. Let's look at an example. A researcher wants to test if there is a correlation slash relationship between the ICE test and the AQ test. Okay, so for those of you who studied the Baron-Cohen study, we are looking at a relationship between the ICE test and the AQ test, which means will people score high in the ICE and low in the AQ, which will be an inverse correlation, or will they score high in both? So the score high in the ICE test, will they also score high in the AQ test? That should be a positive correlation. Okay. Keep in mind, I'm not saying that a higher score in the ICE test is the reason for a higher or lower score in the AQ test, because if I do that, I'm changing ICE test to the IV and AQ test to the DV, and this will no longer be a correlation because we're not testing cause and effect. We're not testing IV DV. This is a correlation. We're just looking for a general relationship. Right A, and for those of you who are not familiar with this study, you can look at my presentation. I've posted it on my YouTube channel on Baron-Cohen. It's an easy study. Write a one-tailed directional hypothesis for this correlational aim. The ICE test and the AQ test will have a negative correlation. And you know what? I've actually gone on to kind of describe it just to impress the examiner. As an individual who scores high in the ICE test would score low in the AQ test. So I'm explaining why there's a negative correlation, that you're scoring high in one test and low in the other. If you want, you can just simply say that the ICE test and AQ test will have a negative correlation, but just to be on the safe side, it's better to maybe just elaborate a bit more on it and kind of explain why it's a negative correlation. So that if you score high in the ICE test, you're scoring low in the AQ test. Write a two-tailed or non-directional hypothesis. There will be a correlation between the ICE test and AQ test. Okay, so I'm saying that there is a relationship, but I'm not specifying if it's negative or positive. In the first one, I did. In the first one, by the way, if you wanted to say that the ICE test and AQ test will have a positive correlation, that can also be correct. Now, for those of us who studied this particular study, we know that the two tests do have an inverse correlation. So if you write that they will have a positive correlation, you shouldn't be marked incorrect because again, it's a prediction, right? We're assuming that we haven't done the study as yet. So I will say that I am predicting that this will happen, that there will be a positive correlation. So you can't go wrong with your prediction. You can never be marked wrong on your prediction because it hasn't happened. We're assuming it hasn't happened. So if you wanted to write a positive correlation, you can say the ICE test and AQ test will have a positive correlation, as an individual who scores high in the ICE test would score high in the AQ test as well. Okay. Two-tail, pretty straightforward. There will be a correlation between the ICE test and AQ test. Try to think of the null hypothesis now. So I'll give you a few seconds to come up with what you think the null hypothesis should be for this. Remember, there are two types. You can write either one. Okay, so let's look at what the null hypothesis is going to be. There will be no correlation between the two tests, or any relationship or correlation between the two tests is due to chance. Okay. Pretty easy, pretty straightforward. Okay, another example, another correlational example. A researcher wants to test if there is a relationship between happiness and intelligence. Write a one-tailed directional hypothesis. Happiness and intelligence will have a positive correlation, as an individual who is more happy will be more intelligent. But I'm not saying that happiness is the reason for intelligence, okay? Because this is not an IVDV. You can even say that happiness and intelligence will have a negative correlation, as an individual who is happy is going to be less intelligent. Write a two-tailed non-directional hypothesis. There will be a correlation between happiness and intelligence. Write a null hypothesis. There will be no relationship between happiness and intelligence, or any relationship between happiness and intelligence is due to chance. Okay. New scenario now. Sometimes the hypothesis is given to you and you have to identify if it's a one-tailed or two-tailed and give a reason as to why you think it is. So here's a twist now. They will already not operationalize, they will already write down a one-tailed, two-tailed, or null hypothesis, and they will ask you whether you think this is a one-tailed hypothesis, a two-tailed, or a null hypothesis, and you have to give a reason as to why you think it is what it is. So let's look at a few of those examples. Question number 6, a hypothesis, let me try and make it slightly bigger. Okay. A hypothesis for an aim is people will be aroused more when they are shown negative images than if they are shown neutral images. State the type of hypothesis and give a reason for your answer. Okay, people will be aroused more when they are shown negative images than if they are shown neutral images. So images are causing an arousal. So if something is causing or affecting the other, then we know that this is an IVDV. So the images being negative or neutral would be the IV, and arousal would be the DV. So we've identified the IVDV. Now, is the question showing ambiguity, or is it being definitive in which variable is having a greater impact? And I think it's the latter. It's saying that people who are shown negative images will be more aroused than those shown in neutral images. This should be a one-tailed hypothesis because the result, the behavior of arousal, is clearly being affected more by negative images. It's saying negative images will have a greater impact on arousal than neutral images. So one variable is being favored over the other when it comes to the behavior, when it comes to the arousal that is being created in the participants. So the reason for this is because the result is being given a direction. It's being given a direction towards negative images as opposed to neutral images. If it had been given a direction towards neutral images rather than negative, that would have still been a directional hypothesis, as long as one is being favored over the other. This is a one-tailed hypothesis as the result is being given a direction, as it is stating that negative images will cause more arousal than neutral ones. Let's look at question 7. A hypothesis for a study is there will be a difference in the helping behavior of chimpanzees depending on whether they can see each other or they cannot see each other. So whether they can or cannot see each other is the IV, and their helpfulness is their DV. So there will be a difference in the helping behavior of chimpanzees depending on whether they can or cannot see. This should be a two-tailed hypothesis because I'm not saying that they will help each other more if they can see as opposed to if they cannot see. I'm saying that there will be a difference, either in the can see condition or in the cannot see. So they will perform better in one than the other, but I'm not specifying. So when I'm not specifying, but I am saying that there is a difference, then that is a two-tailed hypothesis. So this is a two-tailed hypothesis because there will be a difference in the helping of chimpanzees, but the result is not being given a particular direction. So it could be higher for the can see or for the cannot see. You do not need to elaborate as much as I have over here. I've elaborated only so you guys understand. You can simply say that this is a two-tailed hypothesis because it says that the difference in chimpanzees is because the difference in the chimpanzees helping is not being given any particular direction. You can end it there. Okay. Let's look at another one. A hypothesis of a study states there will be no difference in aggression depending on whether a child is a boy or a girl. State the type of hypothesis, give a reason for your answer. This is a null hypothesis because it says no difference. Okay. So this is a null hypothesis as it is rejecting the aim and saying there will be no impact of the gender of the child on the aggression they show. If this was there will be a difference in aggression depending on whether a child is boy or girl, it will be a two-tailed hypothesis because um, the direction isn't specified, but there it is stating that there will be a difference. If it said that children will be more aggressive if they're boys as opposed to girls, this would be a one-tailed hypothesis because there is a direction being given to the result. Okay. Okay, next slide. Also, by the way, if for the previous one, had they said something like any difference in aggression shown by boys or girls is due to chance, then you would say that this is a null hypothesis because the aim is being rejected and there is no particular direction being given to the results. Okay, finally, the question. So, this is again operationalization. So, this is the one where students maybe struggle the most. It's the trickiest one. Also, by the way, another example of the previous type. Let's give a correlational example now. Let's say variable A and variable B are positively correlated. What type of correlation is this and why? You would say it's a directional sorry, what type of hypothesis is this and why? You would say it's a directional hypothesis because they've been given the direction of a positive correlation. Okay, if it says that there is a relationship, then you would say it's two-tailed, but the direction is not specified. And if it says there is no relationship, then you would say it's a null hypothesis because it's rejecting the aim altogether. Okay, so let's look at studies now where you're required to operationalize the variables. A researcher wants to test if there is a difference in playfulness of children depending on their ages. Write an operationalized one-tailed directional hypothesis. Now, I explained to you that operationalization of the IV is how we define the IV, right? Which basically means you just describe the two conditions of the IV in a bit of detail. Operationalization of the DV, however, is something else. Operationalization of the DV is how we are measuring the DV. The DV is always a behavior. I gave you the example of the race of the victim in Pilyavin and the IV, that's the IV. It was operationalized by a black victim or a white victim. Another IV example was the condition of the victim operationalized by a drunk victim or an ill victim, right? So that's the IV operationalization, just elaborating a bit, describing the IV basically, the conditions of the IV. What was the DV in Pilyavin? The DV or dependent variable in Pilyavin was the helping behavior of the participants. How do we operationalize helping behavior? How do we measure helping behavior? In other words, how is helping behavior recorded? How do we quantify helping behavior? How do we get quantitative data or results to show that the participants displayed helping behavior? That is operationalization of the DV. How did we measure helping behavior? By the number of participants who helped and the time it took for them to help. That is the operationalization of helping behavior. What was the dependent variable in Milgram? It was the obedience of the participants. How was that measured? How was that operationalized? That was done by recording the number of maximum voltage of shocks that each participant administered. Let's look at hypothetical examples. I want to see if the AC will affect performance of students in a test. Performance is the DV, and how can we operationalize performance of students in a test? That will be through the marks that they get in a test. Okay, so any quantifiable manner by which you are measuring the behavior of participants is essentially the way you're operationalizing it. And you can do that in two ways. You can use an observation or you can even use self-report. For example, I want to see how happy you are. Let's assume happiness is the DV and the IV is the weather. I want to see if weather affects your happiness. So if I were to operationalize the IV of weather, I could say rainy weather or sunny weather. So I want to see if you're happy during rainy weather, rainy season, or during a sunny day, a rainy day or a sunny day. Okay. Happiness is now my DV, and I want to operationalize happiness. How can I measure happiness? If I were to use a self-report, I can give you a rating scale and I can ask you to rate how happy are you from a scale of 1 to 10. But let's say the question specifies that you cannot use a self-report. So you can't ask the participant or you can't ask them to rate how happy they are. So the only other option you're left with is observing them. So what is it that you observe about a person that lets you know that they're happy? Let's say you're looking at two of your friends and you're trying to identify who is happier by simply observing them. So what is the first thing that you notice about someone when you know that they're happy? They're smiling, right? So one way in which you can operationalize happiness by observation is by observing them smile. But how is that measuring? You're not really measuring anything. There's no quantifiable um, technique that you're using over here. You're not getting any quantitative data. You're just saying, I'm seeing them smile. How is that quantitative? That isn't. So you need to elaborate a bit more about what you're measuring about their smile. So you can say how wide their smile is or how long they're smiling for. So if your two friends are sitting and they both are happy and you're saying friend A is happier than friend B, and I were to ask you, how do you know that? You would say because friend A was smiling longer than friend B, or friend A was smiling with a wider smile than friend B. Okay, so this is just an example of how you can operationalize certain behaviors that are difficult to quantify, right? Let me give another example. I want to operationalize, let's say people go to the gym, and I want to operationalize the behavior of how tired they get or how much energy they have, let's say energy levels. Okay, I give them energy drinks, Red Bull, and let's give, okay, coffee and Red Bull. Okay, let's have these two as my IV conditions. So operationalize my IV as um, one glass of coffee, 1 cup of coffee, or 1 can of Red Bull. Okay, same quantity. So that's my IV. That's how I've operationalized my IV. My DV is their energy levels. I want to see how energetic they are. How can I measure someone's energy levels? Well, one is I can ask them in a questionnaire, but a better way would be to operationalize it by observing them. What is it that you're observing about them? If let's say they're going to the gym, what is it that you're observing that allows you to see that they are, um, they're showing high levels of energy? You could say how long they are running on the treadmill. Okay, how fast they're running on the treadmill before stopping. Okay, how intense their workout is, how many um, reps they're able to perform in a workout, how long they're at the gym for. Okay, so you can come up with whatever appropriate way you deem suitable for operationalizing your behavior of energy. So similarly, any behavior that you want to operationalize, just use a bit of common sense. Just try to use your intellect and try to come up with a common sense answer, but try to quantify it. Say how long or how much they're doing that particular behavior. Okay, and try to be a little more elaborate and detailed with it. So let's look at a few examples. A researcher wants to test if there is a difference in playfulness of children depending on their ages, write an operationalized one-tailed directional hypothesis. So let's look at the answer over here. So the first step is we have to operationalize both the IV and DV. The mistake students make here is they only operationalize the IV, they don't operationalize the DV. Or they only operationalize the DV and not the IV. You have to operationalize both variables, not just one. So a researcher wants to test if there is a difference in playfulness. So we have to operationalize playfulness depending on the ages of children. So age of children is the IV. Let's operationalize the age of children. They haven't mentioned the age, they just said different ages of children. So we can come up with our own two conditions for that. We can operationalize it ourselves. So let's have children who are, let's see the example I've given. So I've operationalized the ages of 2 to 5 and 6 to 10. So younger children and older children. And I've gone into the details of saying younger children will be 2 to 5 and 6 to 10. Okay, so I've operationalized. So let's see what it says over here. The first step is to operationalize the IV. The IV is ages of children. You can choose how to do this. For example, have one group of children aged 2 to 5 and the other aged 6 to 10. Okay, if you want something different, you can. If you want a group of 2-year-olds and you want a group of 10-year-olds, you can have that. If you want a group of 5-year-olds and a group of 12-year-olds, up to you. The second step now is to operationalize the DV. The DV is playfulness. How do we measure playfulness? How do you measure whether someone is playing or not more than someone else? How much time they're spending in a particular game? So let's be a little more detailed with our operationalization for playfulness. How long the child is playing catch with the ball? Okay. How long a child is playing cricket? How long a child is playing soccer? Okay. Um, how long the child is playing on a video game, for example. Okay, so you can come up with whatever way you deem suitable for your answer. So children age, so once I've identified, and you don't have to write the operationalization separately in your answer, you just need to come up with it in your own head. You can write it with a pencil on the side so you don't forget. But once you've thought of the operationalization for both the IV and the DV, then you need to phrase it in the form of a hypothesis. So we can say that our operationalized one-tail hypothesis would be children aged 2 to 5 will be more playful and play longer with the ball than children aged 6 to 10. Or children aged 6 to 10 will be more playful and play longer with the ball than children aged 2 to 5. Now, if I had written children aged 2 to 5 will be more playful than children aged 6 to 10, then that is not completely correct because I've only operationalized the age, not playfulness. Okay, I'll repeat. If I say children aged 2 to 5 will be more playful than children aged 6 to 10, and this entire statement and will play longer with the ball, let's say I don't add this, then I haven't operationalized the DV of playfulness. This is very important. I have to say how they are more playful by saying they will play longer with the ball. Let's say I say, okay, let's look at the example of two-tail, but let's look at another way that you can operationalize it. Younger children will be more playful by playing catch longer than older children. Okay, so over here I've operationalized it as younger and older. I would go with this one because this is more detailed, and the more detailed your operationalization, the better. But both are correct. Let's look at a two-tailed operationalized hypothesis. Write an operationalized two-tailed non-directional hypothesis. There will be a difference, so the same phrasing, but this time we're operationalizing it. There will be a difference in how long the children play with a ball depending on whether they are aged 2 to 5 or 6 to 10. Okay? Or there will be a difference in how long children play with a ball depending on whether they are younger or older. That's also correct. Had I written there will be a difference in playfulness of children depending on whether they are aged 2 to 5 or 6 to 10, again, same problem. I would not have operationalized playfulness. Had I written there will be a difference in playfulness depending on the age of the children, I would not get full marks. If I write there will be a difference in playfulness of children depending on their age, that would only be completely correct if the question had not specified operationalization. So if the question, like the first few examples, if the question was simply a researcher wants to test if there is a difference in playfulness of children depending on their ages, and the question was write a one-tailed hypothesis, not operationalized, just a one-tailed hypothesis, then I could say younger children will be more playful than older children. For two-tailed, there will be a difference in playfulness depending on ages of children. That would have been fine. But because they're saying operationalization, then you should operationalize it. Questions that students ask, what if they're not asking for operationalization? Should we still operationalize it? There's no need. Unless if they haven't specified the two conditions of the IV, then you can very briefly operationalize it. For example, the first example we looked at, the lighting affecting the productivity of workers. Now, in that, it did not mention the conditions of the lighting, so we had to operationalize it, but we didn't feel any need to operationalize the productivity. So we simply used the term productivity because it wasn't asking for operationalization. If it had, then I would say that productivity of workers would be greater as they would produce more units of a product. Okay, so I would operationalize it that way. So over here, because it's saying operationalized, I have to be a little more detailed in my answer, in my sentence, in my statement. So there will be a difference in how long the children will play with a ball depending on whether they are age 2 to 5 or 6 to 10. Okay, so operationalize both the DV and the IV. Right, an operationalized null hypothesis, there will be no difference in how long children play with the ball depending on whether they are age 2 to 5 or 6 to 10, or any difference in how long children play with the ball depending on whether they are age 6 to 5, sorry, 2 to 5 or 6 to 10 is due to chance. If I write there will be no difference in playfulness depending on the ages of the children, that is not operationalized. If I write there is no difference depending in playfulness depending on whether children are age 2 to 5 or 6 to 10, that is also not completely correct because I haven't operationalized playfulness. If I say there will be no difference in how much time children spend playing with the ball depending on their ages, that is also incorrect because in this case I have not operationalized the IV. So both IV, DV have to be operationalized in your one-tailed, two-tailed, and null hypothesis if the question is specifying that you should operationalize it. If not, then you don't need to. Another example, the aim of the study by Pilyavin is to see if the condition of the victim will have an effect on the helping behavior of the passenger. So the reason I'm giving a question from one of the studies in the syllabus is because they can do that as well. In the previous example, you had to come up with your own operationalization. You had to come up with, you had to use your brain a bit and come up with your own way of measuring the DV and defining the IV. But for a study in the syllabus where the researcher has already operationalized the IV and DV, then you need to try and remember the way the researcher operationalized it. So you cannot come up with your own operationalization now. You have to use the operationalization the researcher did, or the researcher used. So the IV of the study by Pilyavin was the condition of the victim, and the DV was helping behavior. Now ask yourselves, try and remember, how did Pilyavin operationalize the victim condition? By having a drunk victim and an ill victim. How did Pilyavin operationalize helping behavior? By number of passengers who helped. Okay, once you remember that, just apply it in your phrasing. So write and operationalize one-tailed hypothesis. The number of people who help will be greater for the ill victim than for the drunk victim. Now, notice how I did not write the number of people who helped is greater or was greater, because then I'm giving a result. And you have to be very careful. Going back to the first point that I made when discussing this chapter, a hypothesis is always a prediction. Yes, we've done this study. Yes, we know the results. But if you're writing a hypothesis, we are still assuming that this is something that could happen. Okay, so you have to forget about what has happened and you have to phrase it as what could happen. So do not write the number of people who helped was greater. Very big mistake students tend to make. You will write the number of people who helped will be greater. Okay, prediction for the ill victim than for the drunk victim. Operationalized. If you had written that helping behavior will be greater for the ill victim than drunk victim, that would not be operationalized because you haven't operationalized helping behavior. Write and operationalize two-tailed or non-directional hypothesis. There will be a difference in the number of people who help depending on whether the victim is ill or drunk. If you write there will be a difference in helping behavior depending on condition of the victim, that is not operationalized. That would be correct if they ask you to write a regular directional, non-directional hypothesis, unoperationalized. Because it's asking for operationalization, I've operationalized both the DV and the IV. Write an operationalized null hypothesis. There will be no difference in the number of people who help depending on whether the victim is drunk or ill, or any difference in the number of people who help depending on whether the victim is drunk or ill is due to chance. So for paper 2, make sure you remember the operationalization of the IVs and DVs for all 12 studies. Okay, if the question had not asked for operationalization, then the answer would simply be people will help a drunk victim more than an ill victim for one-tailed. For two-tailed, it will be there will be a difference in helping behavior depending on the condition of the victim. And for null, any difference in helping behavior depending on the condition is due to chance, or there'll be no difference in helping behavior depending on condition of the victim. Okay. Okay. Similarly, they can even give you a correlational question where you have to operationalize it. So I'll write an example over here. Let's take the first one of the correlational examples. A researcher wants to test if there is a correlation between, what was it? Happiness and intelligence, right? Happiness and intelligence. And let's say part one is to write an operationalized directional or one-tailed hypothesis. So for a correlational study, we have to identify the two variables, happiness and intelligence. And the way we operationalize the variables in a correlation is the same way we operationalize the DV. Okay, so we have to measure them. So we measure happiness, we measure intelligence. How can we measure happiness? I gave you the example, how much a person smiles. How can we measure intelligence? If you say how smart a person is, that's not elaborate enough. How can I measure how smart a person is? Remember, you have to be very detailed when it comes to operationalizing or measuring variables. So simply saying how smart a person is not enough. How do you measure? So you say, okay, fine, how smart a person is. I will ask you, how do you know the person is smart? Then what will you say? Then you will say, because they got a high score in an IQ test. So that's basically the way that you measure intelligence, your scores in an IQ test. Okay. So I could say that my one-tailed hypothesis for this operationalize would be there will be a correlation between how much a person smiles and there will be a positive correlation between how much a person smiles and how high a score they get in an IQ test. Or I could, let's write it down. There will be a positive correlation between happiness and intelligence, as the more a person smiles during a day, the more or the higher their IQ score is likely to be. Okay, you can come up with your own way of measuring each variable. You can, if you don't want to say how much they smile, you can say the more I don't know, maybe the more a person is joking around during a day with friends, the higher their IQ scores are likely to be. Okay. Um, a two-tailed hypothesis operationalized would be there will be a difference in, sorry, no, that there will be a relationship between how much a person smiles and how high their IQ score is. Okay, so that would be a two-tailed, and a null hypothesis operationalized would be for a correlation. There will be no difference in how much a person smiles. So, sorry, there will be no correlation or no relationship between how much a person smiles and how high an IQ score, how high a score they are likely to get in an IQ test. Let's take another example, shall we, of a correlation. Think of any two variables. Let's think of Uh, Time spent on social media and grades that students get. Okay, so I want to see if there is a correlation between time spent by students on social media and okay, fine, let's change it. I want to see if there is a correlation or a relationship in the time spent. So variable one is time spent on social media, and the other variable is um, how social the person is. Okay, so I want to see a correlation between these two. So how can I measure how much time a person spends on social media? Hours spent on, um, let's say, Instagram. Okay, number of hours spent on Instagram. So that's how I'm operationalizing time spent on social media. And how social a person is, number of friends a person has, or how many hours a person spends with friends in a day. Okay, so hours spent on Instagram and how social can be operationalized by um, time spent with friends. So an operationalized one-tailed hypothesis for this correlation would be there will be a correlation, there will be a positive correlation between time spent on social media and how social people are, as the more time people spend or the longer they spend on platforms such as Instagram, the more time they are going to spend with their friends. Okay. A two-tail hypothesis would be there will be a difference in, sorry, I keep giving the example of an experiment. This is a correlation. There will be a correlation or a relationship between how much time a person spends on platforms such as Instagram and how much time they spend with their friends. Okay. And a null hypothesis would be there will be no relationship or no correlation between how much time is spent by them on Instagram and how much time they spend with friends. Okay. Or how many friends they have, or any difference between the two is due to chance. Okay. So this is everything that we need to know for a hypothesis question that could potentially come. If it does come, if any of these come, hopefully, if it does, an easy one will come. If not, if any of the operationalization question comes, hopefully you'll be set. The next video I will upload, I'm going to try and upload it in a few days, will be attempting a paper 2 past paper. Actually, no, because the syllabus has changed, I'll attempt a specimen paper. And we will look at the different type of questions. I will discuss how we answer questions for paper 2. And I will discuss how to design a study also. I'll upload an entire video on that. So the 10-mark design a study question that you're expected to do in paper 2. So a lot of research method content I've been posting recently. So I hope that it's helpful. I hope it's kind of strengthened your concepts of research methods. And hopefully after having covered the specimen paper, you will get a better idea of how to answer questions. So everything that I've been posting these last few weeks on research methods, actually applying this knowledge on questions and learning how to use these points and how to use the terms, because that's where you struggle. That's because you may know the meanings and definitions of the terms, but how to write answers, that's where students struggle. So that's what I'm going to discuss by doing the specimen paper in the next video. I will try and create mock papers, which I'll keep sending you people for practice because we don't have past papers. We do technically for 7 of the 12 studies. So if you guys want 2018 to 2023, you can look at those past papers. You can look at the questions. In fact, you should look at the questions for the other 7 studies, and you can practice questions for those 7 from those past papers. And you can even get an idea of what type of questions they may ask for the 5 new studies, because the exam format, the type of questions are still the same. But I will still keep making example questions and mock papers, which I'll be sharing with you guys for practice, and I'll even discuss some of them in my videos. I said that in March or maybe end Feb, I will go live on my YouTube and maybe on Zoom also. I'll let you guys know on that. And I'll keep some free online classes in which we'll just be covering these mock exams that I'll be making, just to kind of help you guys, prepare you guys for the exams. If anyone has any questions or queries, they can ask during those lectures as well. So yeah, next paper two, and then I will go back to paper one. I will also create a video on answering paper one questions. A lot of you guys are asking me to make content on the biological approach. I have my notes ready. I've shared them with those of you on the group. If anyone is not on the group, I will be posting the link to my WhatsApp group in the description. So please do join. And I will very soon also make videos on the biological approach. So slowly but surely, we will cover everything. I still have a lot more content coming your way. So stay tuned to the channel and hope this was helpful. See you next time. Bye bye.